Acids and bases introduction. You are used to acids as being substances that just release hydrogen ions since they have this hydrogen in their formula. Well, you should also know that the hydrogen ions are pretty much just protons, okay? Because obviously hydrogens have one proton, one electron. When that electron gets removed in order to do the bond, we only have a proton left, right? Because hydrogen only has one proton, one electron. So it's pretty much when the electron is gone, it's just a proton now. It only has one proton. So when it's a proton from the acid and it's attracted to negatively charged oxygens in a water molecule, what happens? Well, it is actually so strong when they bond together that hydronium ions form. This can also be known as ionization. So what does this mean? Moreover, bases, are they just substances that do the opposite? Instead of releasing hydrogen, they release hydroxides since they have hydroxide in their formula? So does this mean the opposite of ionization, also known as dissociation? So it's the breaking up, right? To release hydroxide are bases for certain. So let's look at these two examples down here. Look at this base over here. Okay, this base is KOH. It is aqueous, so it's dissolved in water. So when you dissolve it in water and it breaks apart, we have K plus and OH minus. Okay, OH minus is released because OH is actually in the formula as we wrote it in this statement, right? So is that for certain? Well, let's look at this one down here. This example has an OH minus that got released. However, there is no OH in this base over here. So this is a little suspicious. Therefore, it is more about the acceptance of a proton for a base. Similarly, for acids, it is going to be the opposite, vice versa. It is going to be the release of a proton. So what does this mean? There's a tit-for-tat approach, vice versa, for acids and bases. This is why we deal with conjugate acid-base pairs. Well, what is a first conjugate base? Well, a conjugate base is what remains after that H plus got removed from the acid. So if we look at this one and we look at this one here, look, there's two hydrogens. There's only one hydrogen left. What is remained? Well, as you can see, this is the one that is remaining after that H plus got released, okay? Because we only have one H over here. So technically this here is the conjugate base of its corresponding acid. So this here would be the acid. So what would be a conjugate acid? It's just the opposite. It is pretty much what is remained because it gets formed from the addition of the proton, okay, of that hydrogen. For example, this one here would be the base because, as you can see over here, what has remained after it got formed due to the addition of a hydrogen? Well, there's 4 here, there's only 3 here, so it obviously got added over here. So this here will be the conjugate acid of this corresponding base.